I'm going to chat through how to sketch out this model and what we need to be showing within our model. So you're asked to pick one ionic compound from lesson 2 and sketch it dissolving in water below. So in order to do this, we first need to pick an ionic compound. I've listed them all in the possible ionic compounds document. Okay, so these are the ionic compounds that we talked about in lesson 2. You need to use one of these compounds. Okay, the example that I'm going to go through is for potassium nitrate, which is not one of the compounds that you saw in lesson 2. So you cannot use this example. Okay. All right. So when we're going over here, when we're actually using this, my suggestion is to use the rectangle to make your actual compounds. So let's say that we're going to draw water. Oops. Undo. So you're going to click on the color and then click on rectangle. We're going to make a rectangle for oxygen, and then I'm going to click on text and then click somewhere in this box, and then I'm going to type an O for oxygen. Then I'm going to make my hydrogens. And again, just like a text for hydrogen, and so on and so forth. You're also going to want to, up here it says to illustrate partial charges. So we're also going to want to just make sure that we know that this is negative and these two are positive. Okay. Now, to save you from watching me draw all of this, I've already drawn it in another screen. So here I have my water molecule. So I have oxygen, I have 2 hydrogens, and I have the hydrogens labeled as positive, I have oxygen labeled as negative, and then I have my ionic compound. I have potassium in the blue box, and I have nitrate in the pink box. Okay, then my after, if we look at the actual formula here, my after is potassium, which is positive, and nitrate, which is negative. So then looking here, I have potassium hanging out by my oxygen, which is negative, and nitrate hanging out by my hydrogen, which is positive. Okay. The thing that I did not detail here that is useful information is that we had a decrease in temperature after the compound dissolved. We had a decrease in temperature. So that's what we want to actually think through down here with the energy. So to make this simple, I'm going to click black and then click rectangle. And I'm just going to draw rectangles here to show how much energy we actually have for each of these substances. Oops. Okay, so I'm just drawing 3 for each. It doesn't matter how you're sketching these out. Like, you can sketch them out this way. You can also just draw. It's fine. Okay, so I had a temperature decrease, but we need to think about where was that temperature actually decreasing from? So the thermometer was in the water, and we have defined the water as the surroundings. So the water got colder, meaning the water lost energy. So here I have 3 boxes in the surroundings, or 3 boxes for energy in the water. So over here, I'm going to only sketch 2. Okay, something happened there. My surroundings now have less energy. They have colder temperature. That energy had to have gone somewhere. The only option we have is for that energy to have gone into the system. So that means the system now has more energy. The thing that you want to make sure that you're doing here is however many boxes of energy you have shown here. So here we have 6 different boxes of energy. Here we also have 6 different boxes of energy. you want to make sure that you're showing a conservation of energy. Here, up here in the boxes, we want to show a conservation of matter. Down here, we want to show a conservation of energy.